James' achievements on the Webb have exceeded our expectations, consisting of a 6.5-meter mirror, a sun shield the size of a tennis court, and a complex array of instruments cooled to temperatures near absolute zero. The telescope observes the sky in infrared radiation, revealing details of the universe just after its birth 13.8 billion years ago. It captured images of stars born in clouds of dust and collect faint lights from the deepest of the universe, exploring its darkest corners. The infrared instruments of the space-time network are also useful for studying strange and bizarre worlds. In particular, James Webb has focused on Proxima B, capturing the sharpest image of our closest known neighboring exoplanet. What's fascinating is that what he has revealed goes beyond our expectations. In January 2024, we have reached a remarkable milestone in our understanding of the universe. For millennia, humans have observed the sky, wondering about points of light in apparent infinity. Just 3 decades ago, we began to discover planets orbiting other stars through a variety of methods. Now, 55 confirmed exoplanets and 10,000 additional candidates. We are in a new era of astronomy, exploring fascinating and diverse worlds beyond our own solar system. Planet formation exhibits remarkable diversity, determined by a number of factors including the chemical composition, geological activity, and atmospheres. When findings point to the presence of worlds with chemical elements, even superficially related to life, the discoveries are significant, providing answers to some of our questions about the cosmos. However, deeper questions remain. In this context, the mission of the James Webb Space Telescope is focused on exploring the atmospheres of exoplanets for signs of life in other corners of the universe. Although James Webb is an infrared telescope, which raises the question of its suitability for studying exoplanets, it will use the transit method for this purpose. This method involves observing the light from a star as a transiting planet passes between the star and us. Collaboration with ground-based telescopes will complement this research by allowing measurements of the mass of planets using the radio velocity technique, which detects the slight wobble induced by a planet's gravitational tug. In addition, James Webb will perform spectroscopy of planetary atmospheres and carry coronagraphs to obtain direct images of nearby exoplanets. Although these images may appear to be simple points of light, their detailed analysis will reveal valuable information, such as color variations that may indicate seasonal or rotational differences in vegetation. Spectroscopy, which involves measuring the intensity of light at different wavelengths, is fundamental to unraveling the atmospheric compositions of exoplanets. When a planet transits in front of a star, starlight passes through its atmosphere, and the elements and compounds present in the atmosphere absorb light at characteristic wavelengths. This absorption is reflected in the observed spectrum, making it possible to identify the presence of elements such as sodium, methane, or water. An infrared telescope is essential for characterizing the atmospheres of these exoplanets because many of the gases relevant to the search for life, such as water and carbon dioxide, emit and absorb light in the infrared range. In addition, this wavelength provides valuable information about the temperature and chemical composition of the atmospheres, which contributes significantly to our understanding of the habitability of these distant worlds. Observation in the infrared spectrum offers the advantage that the molecules present in the atmospheres of exoplanets exhibit a wide range of spectral characteristics. The ultimate goal is to discover a planet with an Earth-like atmosphere, and in this effort, to find an Earth 2.0, the James Webb Telescope has turned its attention to Proxima B. This enigmatic exoplanet, located light years away, is the closest known neighbor. Proxima Centauri B is a super-Earth orbiting an M-type star with a mass approximately 1.27 times that of Earth and an orbital period of 11.2 days. This planet lies at a distance of about 0.085 astronomical units from its star within the habitable zone. However, the extreme intense ultraviolet radiation it receives from its star poses challenges to habitability, as this radiation can erode the atmosphere and compromise the presence of elements essential for life, such as oxygen and nitrogen. The habitability of a planet depends not only on its location in the habitable zone, but also on the ability of its atmosphere to maintain conditions suitable for life, such as climate regulation, radiation protection, and preservation of necessary chemical components. In addition to Proxima B, James Webb is also interested in other exoplanets, such as WASP 107b and the Wandering Worlds of the Orion Nebula, which challenge our conventional conceptions of planetary formation. These recent discoveries have opened up new questions about the formation and diversity of objects in the universe, challenging our existing theories and stimulating continued explorations of the cosmos. We were on the lookout for astronomical tiny objects, and we have found them, even as small as half of mass of Jupiter, floating freely in space, unbound to any star. Physics tells us that objects of such a small scale should not exist, but we seem to have defied those laws. These bodies, which are technically not planets, have been dubbed Jupiter mass binary objects because several of those identified come in pairs. Although these two jumbos are 2 of 1,000,000 years old, which is very young in astronomical terms, their first surface temperatures reaching a scoring 1,000 degrees Celsius, although they will eventually cool. Although these objects may exhibit interesting atmospheric features, such as the presence of steam and methane, they are not considered capable of harboring extraterrestrial life, as their surfaces could not sustain liquid water, even during their brief period of moderate temperature. These observations have focused on the Orion Nebula, a region of massive star formation located 1,344 light-years away from Earth. This nebula, visible to the naked eye as a fuzzy star in the sword of the constellation Orion, is a celestial spectacle filled with clouds of dust and gas, where explosions and gravitational collapses occurred and give rise to formation of stars and other celestial objects. The most recent findings have puzzled astronomers, especially the presence of numerous pairs of Jupiter-sized objects. The question of how these objects can be flown out of a star's orbit in chaotic interactions and then rejoined remains an enigma. Even experts like Professor Matthew Bates, head of astrophysics at the University of Exeter, acknowledged that they have no definitive answer to this anomaly. It seems that our current theories are not sufficient to fully explain these new findings. There is an unknown mechanism that is shaping these objects, something we have not yet considered. This type of discovery is quite unusual and challenges us in our understanding of star formation, an area we thought we understood quite well. It is a surprising result from which we can learn more about. Let us know what you think in the comments box. If you liked the video, remember to like it, share it so it reaches more people, and subscribe so you don't miss out on more content like this.